how information like participant details, major training programs, disability types, and coordination. Good morning, everyone. My name is Ketut Saket, and today I'm here to present our research on the development of web-based vocational training major recommendation system for persons with disabilities at Sentra Terpadu Inten Soeweno. I would also like to acknowledge my team members, Diana, Priyan, and Adioso, and importantly, I want to thank our supervisor, Mrs. Rian Leandros, for her guidance throughout this project. Here is a brief overview of what we'll cover today. First, we'll delve into the problem formulation. Next, I'll present our proposed solution. Then, we'll discuss the methodology. Following that, we'll explore this result and discussion of our system's implementation. Finally, I'll provide a conclusion and outline future recommendations. Let's begin by understanding the background of our project. The rapid advancements of information technology is fundamentally transforming vocational education globally. Sentra Terpadu Inten Soeweno, or STIS, an institution under the Ministry of Social Affairs, plays a crucial role in providing vocational training specifically for persons with disabilities. However, STIS only relies on a manual system, primarily utilizing Google Forms for both participant registration and assessment data collection. This manual approach leads to significant inefficiencies, including data redundancy and limited capabilities for filtering data. Stemming from this background, we formulated several key problem statements that our projects aim to address. Firstly, how can we design a robust web-based system for vocational assessment at STIS? Secondly, how can we effectively integrate assessment results with other supporting data? Thirdly, how can we simplify the online registration process, especially making it accessible and straightforward for persons with disabilities? And finally, how can we reduce the time spent on manual data processing and minimize the human error associated with the current system? Our proposed solution is the development of specialized recommendation system for vocational training programs. This system aims to recommend suitable training partners based on comprehensive assessment results, provide an accessible and user-friendly web-based interface, ensuring a ease of use for all participants, ensure integrated data management, ultimately speed up the decision-making process for training recommendation and significantly reduce human error. Moving on to the methodology. For this project, we adopted the Waterfall methodology. This methodology is a linear sequential design approach. We begin with requirement definition, gathering all necessary system requirements, followed by system or software design, where we plan the architecture and components. Then, implementation and unit testing involve building system and testing individual modules. Next, integration and system testing ensure all parts work together seamlessly. And finally, the operation and maintenance phase, which includes ongoing support and improvements. Moving on to our results and discussion. Let's first look at the key actors and their roles within the development system. We identified two primary user roles. Administrators, these are the staff at STIS managing the vocational programs. Administrators manage participant data, training program data, and disability data. Participants, these are the persons with disabilities seeking vocational training. They can access the system via login, which includes the validation and registration. They can start the registration process and fill out the registration form. They can print their personalized recommendation result. This use case diagram visually describes how these users interact with our system. You can see the administrator on the left managing various aspects like participant data, major data, disability data, and criteria score data. The participant, on the other hand, start the process, fill out the registration form, and print the recommendation results. The Entity Relationship Diagram, or ERD, shown here visualizes the fundamental structure and relationship between the different data entities within our system. It outlines how information like participant details, major training programs, disability types, and recommendation results are interconnected. Now, let's look at the implementation of our system. This screenshot displays the major recommendation results page, a core output of our system. Here, you can see participants' personal details, followed by prioritized list of recommended measures. The system calculates a score for each measure, indicating its suitability based on participant assessment and disability criteria. It also shows whether the measure matches interests, providing a comprehensive view for decision-making regarding training recommendation for students. To access the system, users are directed to a clean and straightforward login page. For new participants, there is a dedicated participant registration form. For administrator, the system provides a clear participant list page, allowing them to easily view and manage all registered participants, including their selected major and type of disability. From this list, administrator can quickly access the detailed recommendation result page for each participant. Majors list page allows administrator to view and manage all available vocational majors within the system. From majors list page, administrator can navigate to the compatibility score list page. This page is where the specific compatibility scores for each major across different disability types and based on criteria like education, communication, activities, and health are managed. This control ensures that the recommendation algorithm, which utilizes the Prometheus algorithm, is accurately configured. Finally, we have the user profile page where users can update their profile information and manage their account details, including changing their password. We conducted thorough system evaluation and testing. Our user acceptance testing (UAT) involved running multiple test scenarios. As you can see from Table 1, all 14 test scenarios, ranging from admin login to manage disability data and user accounts, passed successfully. This indicates a 100 pass rate, demonstrating the functionality and the reliability of the system. Beyond functionality, we also evaluated the system usability using the System Usability Scale, or SUS. Our system achieved a SUS score of 70 out of 100. According to the standard SUS score interpretation scale, a score of 70 is categorized as OK and corresponds to a C grade. In conclusion, the study successfully developed a web-based vocational recommendation system specifically tailored for persons with disabilities at Sentra Terpadu Inten Soeweno. By adopting the Waterfall methodology, our project effectively replaced the previous manual and inefficient registration and assessment process with a sufficient digital platform. This platform was built using Waterfall for the backend and React.js for the front end. This is all supported by MySQL database. Key features implemented include a secure login system, comprehensive disability criteria management, and the integration of the Prometheus algorithm to enhance the major matching process for the vocational recommendation. Looking ahead, we have several feature recommendations for further enhancing the system. We recommend implementing a feature that allows administrators to create and customize dynamic registration form templates, offering greater flexibility. Introducing a comprehensive participant tracking feature will enable monitoring of progress throughout the training. Here are the references that inform our research. Thank you for your time and attention.